Assalamualaikum and hi everyone. Today our group will present about gravimetry analysis, that is the determination of sulfate ions in water.
Analytical chemistry is the branch of chemistry that focuses on identifying, separating, and quantifying chemical substance. It provides accurate information about the composition of material. Other than that, gravimetric analysis is a classical method of quantitative analysis where the amount of substance is determined by converting into a stable in-solid compound and measuring its mass. Other than that, sulfate ion is a negatively charged particle found in natural water. They originate from mineral, industrial waste, and environmental process. Gravimetric analysis is the one oldest and the most reliable method in analytical chemistry. It involves converting the substance of the interest into a stable, insoluble compound, isolating it, and weighing it. These steps include precipitation, the analyte react to form in solid. Filtration, the solid is separated from the liquid. Drying, the precipitate is dried or heated to remove moisture. Weighing, the mass of the pure compound is measured. This advantage of gravimetric analysis very accurate and precise, more require simple equipment and provide result that can be trusted for standard. Other than that, limitation is time consuming, require careful handling to avoid contamination. Lastly, only suitable when a stable precipitate can be formed. Sulfate ions are negatively charged polyatomic ions made up one of sulfur atom bonded to four oxygen atoms. They are commonly found in natural waste and play a significant role in environmental chemistry. Source of sulfate ion: natural minerals such as gypsum and Epsom salt, agricultural fertilizer that leach into soil and water, industrial process like mining, paper production, and chemical manufacturing. Properties: highly soluble in water, can form insoluble salt with certain cation, especially barium. Chemically stable, making them precise in environmental. Importance of sulfate ion in water. Water quality indicator. High sulfate level affect taste and stability. Important for monitoring pollution and environmental health. Health impact. Excess sulfate in drinking water can cause diarrhea and laxative effect. Safe limits are set by health authorities to protect consumer. Other than that, industrial concern. Cause scaling in boiler, pipe, and cooling system. Lead to higher maintenance costs and reduced efficiency. Environmental monitor. Help detect contamination from mining, fertilizer, or industrial waste. Essential for protecting aquatic ecosystem. Theory, principle of gravimetric analysis. The principle is based on forming precipitate of known composition, filtering, drying, and weighing it to calculate the amount of analyte. Precipitation reaction. In sulfate determination, sulfate ion react with barium ion to form barium sulfate, which is insoluble in water. This formation of barium sulfate.
Next, I will explain the methodology used for the determination of sulfate ions in water. The first step is sample preparation. First, the sample is dried in an oven at a temperature of 105 to 110 degrees Celsius and then cooled in a desiccator. Then, about 0.35 grams of the sample is weighed accurately and then transferred into a beaker. Distilled water and dilute hydrochloric acid are then added. So, the purpose of this step is to obtain a dry and accurately weighed sample. Dilute hydrochloric acid is added to dissolve the sample completely and to prevent interference of other ions during the precipitation process. Moving on is the precipitation of sulfate ions. The purpose of this step is to convert sulfate ions into insoluble barium sulfate. Firstly, the solution is heated to approximately 90 degrees Celsius. Then, barium chloride solution is added slowly while stirring continuously. As a result, a white precipitate of barium sulfate is formed. So, barium chloride is added slowly to produce larger crystals, which can be filtered more easily and improve the accuracy of the analysis. The next step is ashing and heating. The filter paper containing the precipitate is placed into a crucible. It is then heated gently at first and the temperature will increase gradually until the filter paper is completely burnt. Strong heating is then continued. The purpose of this step is to remove the filter paper and obtain pure barium sulfate. Gradual heating will prevent the filter paper from burning too rapidly, which could cause the loss of the precipitate. Lastly is the cooling and weighing process. The purpose of these steps is to determine the mass of barium sulfate accurately. Firstly, the crucible is cooled in the desiccator and then weighed together with the barium sulfate precipitate. The heating, cooling, and weighing steps are repeated until a constant mass is obtained. Obtaining a constant mass will ensure that all the moisture has been removed and that the measured mass is reliable. After the procedure completed, an example calculation is shown using three types of water sample, which is lake, river, and also tap water. The sulfate concentration is calculated using this equation. Sulfate concentration in milligrams per liter is equal to the mass of barium sulfate and multiplied by the conversion factor, which then will be divided by the sample volume. The conversion factor is obtained from the ratio between the molar mass of sulfate and the molar mass of barium sulfate. Using this calculation, the sulfate concentration for river is then obtained is 148.14 milligrams per liter. Lake is 205.75 and lastly tap water is 41.15 milligrams per liter. Based on the result, lake has the higher sulfate concentration. Meanwhile, river is the second higher, which contain 148.14 milligram per liter. And lastly, the tap water containing the lowest sulfate concentration. These results indicate that sulfate levels vary among different water sources. Higher sulfate concentration in natural water bodies may be associated with environmental factors or pollution sources, whereas tap water has the lowest concentration due to water treatment processes. Therefore, monitoring sulfate concentration is important to assess water quality and ensure that water remains safe for use.
There are many applications in daily life of determinations of sulfate ions in water. The first one is drinking water quality monitoring. Sulfate analysis is important in drinking water quality assessments because it have a high sulfate concentrations can affect the taste of water and may cause the gastrointestinal infects such as diarrhea, especially at the concentration above 500 mg per L. Regular monitoring helps ensure that water remains safe and acceptable for consumer. The second application is river and lake monitoring. The determinations of sulfur level in river and lakes helps identify the pollution sources such as industrial discharge, mining activity, and agriculture runoff. Also, monitor sulfur concentrations provide valuable information on the health of aquatic ecosystem and support effective environment management. The third application is industrial wastewater treatment. In this area, many industries release sulfate-containing effluents into water body. Not only that, sulfate analysis is used to evaluate treatment efficiency and ensure compliance with environmental regulations before water waste is discharged into the environment. The last one is environmental protections. In this case, monitoring concentration helps detect water contaminations, protect aquatic life, and prevent deterioration of water quality. Sulfate assessment is therefore an important component of environmental monitoring program worldwide. In conclusion, gravimetric analysis is a relevant method for determining the sulfur ions in water through the precipitation of barium solvent. The method provides a precise quantitative and is widely used in environmental and water quality analysis. Besides, sulfur monitoring is essential because elevated sulfur concentrations can affect drinking water quality, contribute to corrosion, and indicate potentially environmental pollutions. Therefore, the determinations of sulfate ions play an important role in maintaining safe water supplies and protective aquatic ecosystem.